Welcome back, Honors Algebra 2. It is time for Day 7 notes. Hopefully your quizzes went well. Shout out to 8th hour Matt W., Lauren, Devin, and Jesus. And hopefully you guys are all watching this. We're going to prove secant and tangent. Then I'm going to give you guys the trig functions. And then we're going to do 2 problems. So this shouldn't be too long, but we'll see. So first thing, warm up. Basically you have to tell me sine, cosine, and tangent are positive or negative depending on what quadrant they're in. So right now I want you to pause the video and just put a plus or minus sign in this little grid here. For example, first quadrant, sine is positive and cosine is positive. X and Y are both positive, which means tangent's positive, because when you divide those you get a positive. So pause the video and try 2, 3, 4 real quick and see what you get, and unpause. Alright, so here we go. In quadrant 2, X becomes negative. Sine stays positive because we're still up in the y direction, but because when you divide these you have a positive and negative, tangent's negative. Now in quadrant 3, these are both negative because it's left and down, which means tangent's positive. And finally, the x is positive, the y is negative, and tangent's negative. So hopefully you guys saw or did that correctly. Okay, so now we're going to prove that tangent is equal to sine or cosine using similar triangles. The first triangle is just a standard unit circle triangle. We have cosine and sine and 1. So there's my 1 triangle. I'll write it out here. Now, a tangent goes from the point here up to there. So if I draw this triangle in, this is the tangent right here. So, now you will not have to do this on in terms of a test, but I'm just showing you where they came up with these things. And then if you look at the bottom here, the bottom of the big triangle is the radius. Well, on a unit circle, the radius is 1. So, and since these share a right angle, and they share another angle, we have angle-angle similarity from geometry. So we can come up with a setup. We could say tangent over 1 is equal to sine theta over cosine theta. And sure enough, we just proved it. We don't have to do anything at all, because tangent over 1 is tangent. Okay? All I did was just show you that that's the same. Alright, so secant. What a secant is, I'll show you that now. I have the same cosine-sine triangle. And I have the same triangle with the tangent that goes from there. The secant is the hypotenuse of this. This is the secant. Okay? So let's draw our triangles again. And on the homework it says prove cosecant and cotangent. It'll give you what those lines are, so all you have to do is draw the 2 triangles again and then just come up with a proportion, and then you can prove them. So I know this is 1 and I know this is secant. Well, since I'm trying to prove secant, I'm going to make it secant over 1. So secant over 1. Oh, I can't do that. This is 1 here. I forgot to put that in. The radius of the small triangle is also 1. We need that there so we can actually do this. So secant theta over 1. So this over this is equal to the hypotenuse of the other one, 1 over that corresponding side, which is cosine theta. So that's saying that the secant of an angle is the same thing as the reciprocal of cosine. Alright? So here are all of them. I just gave them to you. You guys should know that sine is y over r, or y in the case of a unit circle. Cosine is x over r, or x. And tangent's y over x, or sine over cosine. We have 3 new ones. One's called cosecant. Now the funny thing is cosecant goes with sine, okay? And secant goes with cosine. Basically, cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent, or you can think of it as cosine over sine, because it's flipped over. And we still have our Pythagorean identity, that is 1. So that's all stuff I'm giving you, so let's do this problem. So these are non-unit circle problems. because I'm telling you the cosine's 4/5. It is not one of our unit circle numbers, and the tangent is negative. Okay, so let's think about where this is. Cosine's positive, so my x is positive, I'm over here, but the tangent's negative. So this is either 1 or 4, but out of these two, which quadrant is tangent less than 0? Hopefully you guys realize that it is down here, because negative y gives me a negative tangent. So here's my theta, here's my triangle, and cosine is 4/5. Now, we need to find the other ones. Well, how can I find? I need the other side, right? So I'm going to first use Pythagorean theorem. Oh, I kind of wrote the answer down. I keep writing the answer down, even though that's not the number we have. So we get x squared equals 9, or x equals 3. Now, be careful though. You get 3, but for x and y, we have to keep the sign correct. The radius we don't need to, because it's squared. But the x and y we want in terms of coordinates, so we need to keep those correct. So this is a -3. So I know what cosine is. Basically, I want to know what sine is. I need to know what tangent is. I need to know what cosecant is. I need to know what secant is. And I need to know what cotangent is. Here's a little hint. Get sine, cosine, and tangent first. We have cosine. Sine is opposite over hypotenuse, which is -3/5. Tangent is opposite over adjacent, or y over x, which is -3/4. By the way, this matches up. Tangent is negative, or it was supposed to be, and it is. Okay. Now, cosecant. Remember from the before. Cosecant goes with sine, secant goes with cosine. So cosecant is 1/sine, which is basically flipping that, so it becomes -5/3. Secant is 1/cosine. And if we look at cosine, it was 4/5. This becomes 5/4. Cotangent, we flip tangent. Or you can say it's cosine over sine, but it's easier just to flip tangent in this case. And when you flip tangent, you get -4/3. And that's all you have to do. So we're making triangles kind of like before the quiz when I had a point and you wanted to find sine, cosine, tangent. We're doing the same thing, but we have to work with more trig functions. So number 2 is a little trickier. Everyone have that? Number 2. I have a secant is 13/5 and cosecant is greater than 0. Well, first of all, you have to think in terms of sines and cosines. It'll help you out. Secant is 1/cosine, which means cosine is 5/13. So we're in quadrant 1 or 4 again, because cosine is positive in 1 or 4. So I'm going to just write that out. I don't know which one yet. Cosecant is 1/sine. And they're saying the sine is also positive. So that means we are definitely in quadrant 1. So I'm going to draw a triangle here. And I know the cosine, so it's important to get secant back to cosine, the original one, so you can work with it. It's easier to see. Cosine is 5/13. So 5 for x, 13 for the radius, or the hypotenuse. We have to do a Pythagorean theorem to find our y. I probably should call it y then. So 5 squared plus y squared equals 13 squared. And we have y squared equals 144, y equals 12. Hopefully you guys remember that 5, 12, 13 triangle. If not, you can always resolve for it. So now I have all, and it is positive because it's up in the y direction. So make sure you check that you have the correct sign for the one you solve for. I don't know why I erased that. So now we just have to write out all the other ones. I gave you secant, so I need cosine, I need sine, and I need tangent. I need cosecant, and I need cotangent. Okay. Cosine is 1/secant it's flipped. Well, we already found out what cosine was up there, but make sure you rewrite that one because I need the other 5. Sine, you look at your triangle, it's opposite over hypotenuse, so we have 12/13. Tangent is y over x, so it's 12 over 5. Cosecant is flip of sine, so I'm flipping sine, it's 13/12. And cotangent is the flip of tangent. So I flip tangent and I get reciprocal is 5/12. And that is it. So the key is to get the triangle in the right spot and make sure your numbers are correct. Okay? And that is all. We're going to do a couple more of these together as a class, and then you guys can work on this on the worksheet. And we are done.